welcome to another coding session. So we've got our list, our trusty list of features that we want to work through. And so I had to think about which one I want to cherry pick. And I went for this one, require colon when declaring, which has this as a kind of a follow-up default parameters, because I think the work we do here is going to help with this. So what do I mean by require colon when declaring? So for example, here we are calling glfw create window. We're returning a window, we're declaring a new variable. I want to require that we have a colon here for a new variable. If we had declared a variable of whatever type it is, I think it's pointed to I8 up here, then we could just assign. But when we're declaring, I want to require a colon, and I feel like that just makes it a little more explicit that my intention is to create a new variable here. So then if there's like a lot of space in between here, and then I forget about this, and I say, okay, let's declare window, it'll throw an error, and it'll say, hey, you can't do that because window already exists. That's what I want to do. It's the same in Odin. If I go to like some Odin code, see like this. They normally, all the example code and everything I've seen, they put them together like this. But you don't have to, you could do it like this. And I think in my code, I'd like to do it like this. And the reason is that eventually I'd like to have like multiple returns. And I'd like to be able to go like this for the multiple returns. So like this is creating a new variable, this is an existing variable, and you can do both. I think in Odin you have to do it like this, which means that these are both new variables or both existing variables, but you can't mix and match. And that's my reason for sort of preferring the space there instead of there. Not a big deal really, but anyway, so how do we go about doing this? Well, I've got the grammar open, and I kind of want to, we've got this left-hand side expression for assignments, and I kind of want to split this out a bit. So there's kind of two different possibilities. So what are the possibilities? I want to make a left-hand side declaration. And that declaration does not have a primary in it. Actually, it just has an identifier. It has to have a colon. It can optionally have a type, and it can optionally have an allocator. Like that. Let's have a look at that, see if that looks right. Yeah, identifier, colon, optionally a type, optionally an identifier. This is a little bit different to above. Obviously we have identifier instead of primary, because if you're creating a new variable, you can't do like this. That doesn't make any sense. If window doesn't even exist yet. Likewise, that doesn't make sense. So it just makes sense to have an identifier. The other difference is that previously you had to have a type if you were going to supply an allocator. Now you can do either or, because they're not dependent on each other. The type could be inferred from the right-hand side, but you want to use a specific allocator for this new variable. That's totally fine. So then the other thing is, this is what I want to go to. For a left-hand side expression, it's a left-hand side declaration or a left-hand side primary. Like that. So on the left-hand side, you can have a declaration or a primary. So a left-hand side primary should always be referring to an existing variable. Now, and a declaration is used for new variables. So a declaration should never refer, this identifier in the declaration should never refer to an existing variable, And any identifiers in the left-hand side primary should always refer to an existing variable. Okay, so first place we need to go is parsing of an assignment and change this. Left-hand side, oh, I do keep noticing this, which I want to change. I feel like that's clearer. That's the right-hand side node. Let me just actually check. Is that... Yeah, we use right-hand side node here. Yeah, I think that's clearer. So all we're caring about here is the left-hand side. And it's still left-hand side expression, right? Yeah, it's just that this is going to be different. So left-hand side expression, this here is actually... Oh, am I type checking already? No. Parsing. So this here is actually describing more a declaration now. So let's copy it and say declaration. Declaration. So declaration is a little bit different to what we used to have. Remember, it's an identifier instead of a primary. So we don't have to have LHS. And we have to have a colon. It's not optional. I think this actually can go up here now. So we have to have a colon. We need to make this optional, the type, and then we have an optional allocator. Yeah, that's a declaration. So how do we make this optional? The pattern we use for these kind of things is like this. We make a copy of the stream, which we need to declare, and we pass that in instead. So the main stream doesn't get modified when we're attempting to parse this. And if the parse succeeds, that's when we use the result. And we also update the main stream to reflect the fact that we've parsed the type. So the idea with this pattern is that if this parse fails and this returns false, then this original stream is not modified. So we're still just after the colon as far as the stream is concerned. But if it does succeed, then we update that main stream to be how it would be if we had parsed this primary, and then we continue after that. So that's the declaration. And then this left-hand side expression gets simplified a lot because it's either a declaration or it's a primary. So I guess we can use the same kind of pattern. No, where were we? Here. Oh, that's spelled wrong. There we go. The same kind of pattern, but this time it's we'll attempt to parse a declaration. And if we succeed, then we say this node is the declaration node. You know, we can just say like return declaration node true, like that. We probably don't need the names in this case. I can't remember if I was trying to, I think at one point I was trying to remove the named returns because I felt like it was better without. And then we can probably just do return parse primary. So we try to parse a declaration, and if we succeed, we return it. Otherwise, we fall back to a primary. Declaration or primary. And if that fails, then obviously the whole thing fails also. yeah, so the interesting thing is that with this, we will never get an error. Like if this throws an error, we will never see it, actually. So maybe we need to do something a little more sophisticated like we do for statement. Here we try to parse multiple things, and then we check which one was the most successful, i.e. which one parsed the most tokens, is the idea. So let's steal that, actually. We don't want that here, I don't think. We might need to rethink that also, because we're also never going to get this error. But I think that's okay. I think that with this one, I think it's okay. But with the other one, this one here, I think we should try both. So we can go like this. Oh, this should be parse declaration, right? So we have that, and then we have primary. Like that. So we attempt to parse both, and then we say, okay, which one passed the most tokens? And if declaration did, so declaration stream dot next index equals max next index, that means that declaration stream passed the most tokens, or they may have passed an equal number of tokens. I think that's also fine to choose declaration in that case. And otherwise, we'll return the primary node and update to the primary stream. So we choose which one based on which got furthest. Okay, I think that's better. So I think that's parsing sorted. Now type checking. Ah, that's right. There was one other thing I wanted to do here when we do the declaration. So I think what I wanted to do was, here we add a type node, but we need some way, like later on, when it comes to type checking and generation and everything, we want to know whether it was a declaration or a primary. In generation, we also need to know no, I think that's okay. I think that's okay. Let's try my approach that I was thinking of. So what I was thinking of was that when we parse a declaration, it might have an explicit type, but if it doesn't, we'll add a none type, just a marker to say, like, effectively it's a marker to say this was a declaration. Because an LHS primary, during parsing will not receive a type. So then we can say, then during type checking, when we first get to this point, we can say, hey, is there a type on here? If there is, that means it was a declaration. That's my idea. So let's see how it goes. I'm not sure. So type equals, so it's a type node. And I'm just going to make this a none type. And the other place I thought of that we could use this is nil. So when we're coercing types, if we come across a none type, then it should just be upgraded to whatever else we're comparing it with, right? upgrade types. So we come across a none. Then we upgrade it. That's tokenization. And then here, when we're type checking a nil node, we give it a none type. Hopefully that doesn't destroy nil and nil still works. We do still have some tests with nil, so we can check there by running the tests. So we're going to add this none type node to say this was a declaration. Okay, now we can go to type checking. Type checking an assignment, it's the left-hand side expression. So before we do this, this is where we would get our type information. And actually it has this allow undefined, which should always be false actually. We should never allow undefined when we're type checking a primary. Because like I said before, left-hand side primaries are only for existing variables. Declarations are for new ones. And declarations don't include primaries. Not left-hand side primaries. So confusing. So I guess we need to change that as well. I think we can invert this. So if we come across the case where the identifier did not exist, then we say it's not defined, has not been declared. So that's always an error. It should always be declared if we're coming into here. Okay. So now we can say if, this is where it comes in, like if get type is not nil, that means we're talking about a declaration. And then we should assert that it does not exist yet. Right? Maybe that's kind of what this is doing. Otherwise, and I think we should be able to just leave that none type on there because during like coercion and everything, it should get replaced. I think that means everything will just work out. Let's see, I hope so. So if the type is not nil, that means it's a declaration. And if it's a declaration, the identifier node should not exist. So if it does exist, then we have a problem. Like that. It's already been declared. Yeah, I think something like that. Now, there was a provision in here I noticed for static procedures. That might be an issue because type checking actually has like multiple passes, and in an earlier pass, static procedures do receive a type, even if it's not a, wow, if it's not a declaration? No, that's only for declarations. So that should be fine still. I think, I hope. Okay, let's leave it like this, see what happens. Might have managed to simplify something, which is nice. That's it, it was just the type checking of the left-hand side that changed. I think everything else is fine. Generation of an assignment. So here we're using all these kind of manual checks to see that it's something new, because at this point we don't have any indicator that's come through from parsing and type checking to say this is definitely a declaration. We don't know that anymore. So here we don't make any assumptions. We say if it's an identifier and not a member and not in here, that means that it must be a declaration. And then we do our allocation for it and add it. You know, I don't like that this is adding it all the time. I think, hopefully this doesn't cause problems, but I think it should be just, you know, wherever we're actually allocating on the stack, then we should say that it's in the stack. Like none obviously does nothing, and static adds it to the static vars, so that's something different. I think everything else is the same. Huh, we only nullify for these. I feel like other allocation strategies should still nullify, right? I don't know. Let's put a question mark. And all this should still be the same. During a declaration, we should not allow, like, you know, plus equals, minus equals. That doesn't make sense. So that's probably something we should add to type checking. Actually, what's the GLSL assignment? Does that? If it's something new, then we put the type name at the front. I think that's the type name. Yeah, type name. Yeah, I think that one's fine. Where was I thinking? That's right, type checking assignment. Left-hand side, what did I want to type check? Yeah, assignment. So we do have a bunch of type checking to do with the assignment type. Here we go. So if it's not assign, I guess we need to do a check before here. So if we go declaration is that's how we check if it's a declaration. Left-hand side. And then down here we can say if it's not, so this is equals, this is a regular assignment. So if it's not a regular assignment, if it's like, you know, one of these other crazy assignments, and it's a declaration, that's a problem. Assignment operator is not valid for declarations. We put the type here. I feel like the value would be better, so that it will actually print equals, not like the word equals, it'll print the symbol. I think that's better. Okay. So that's a nice extra check there. We can test that, you know. Blah plus equals I 32.5. I think, yeah, they should give type information, so we don't need to, I mean, we could do this, right? This is kind of what we're checking. Shouldn't be able to do that. That doesn't make sense. Okay, I think it feels like I didn't do that much changes, but I think, oh, that's right. Primaries are always, but they're never allowing undefined, so we'll just take that out. Linux has not been declared. Okay, I feel like we should get a lot of errors like this. This sounds right. Because now that needs to be like that. Let's see if I can find any others. I think that's the only one in this file. Okay, same thing in threading. Any other variables? Stack, PID, these ones already have colons. This is a type alias, but it's still a declaration. Alive. I think that should be it for threading. Okay, memory, allocator, that's another type alias, but a type alias is itself a declaration. We're declaring allocator, right? You know, while we're at it, I did want to, you know, all of my types as a convention I want to have. Oh, that should be a colon actually. I want to have underscore T. Okay. So there's probably a few places where I use these. Thread pool task. Where else? Thread pool task. Thread pool. Okay. Thread pool. I think that's probably, oh, thread pool. Anyway, the type checker will find the rest. There's some in Broomstick. Yeah, I want to consistently have underscore T for all of my types. Vec4 I won't do. Vec4 we're gonna, oh, should we do that now? Maybe. We might do that also, because I want to move that out of here. And it's really not easy, not hard to do. I don't know why I haven't done it already. Let's do Broomstick. So those are declarations. What else we got here? That looks like a declaration. These guys, thread pool task underscore T. Was that it for Broomstick? No. There's a couple of references to a thread pool. Thread pool underscore T. They're both on line 8. I cannot use with type because it doesn't actually know what the type is. Ooh, what a crash. What's this about? Type check identifier. What is the identifier? Thread pool start. Thread pool start is in Broomstick. It's the only place I use it. I wonder what's wrong with that. It's been properly declared. Filter type check identifier. So it realizes that it's a member, and the child node is threading. The child type node is none. Okay. So threading like I give it the type of none in the beginning, but then when we type check this statement, it should get overridden. That's my thinking. But I think that kind of depends on the fact that the left-hand type node does not exist. Yeah. So if we get to this point, we've already type checked the left-hand side, which means that if it was a primary, then it would have got its type. So to get down here and the left-hand side to still not have a type, it must be a declaration, in which case it would not actually be nil. It would have a value of none. And then we would replace it. Let's see if that causes a whole lot of trouble or if it works. I guess that fixed it, because now we're continuing with more errors. Did I do everything in this file? I think I did. I think I did. Confidence is so high. So we're at debug. And I think that's basically it for debug. Core OS. Just needs Linux to be set. So this doesn't have any. I mean, what about this? I think that might be the only place that a variable is declared. So now we got to this example. Boomstick has not been declared. So this should give us an error now, hopefully. Yeah, Simon operator is not valid for declarations. So if I put equals, yeah, now it's going down further. Cool, and window was fine, because I already did that one. This is looking pretty good, I think. These are declarations. So left and bottom. PS time. Sync time. Name. I think we should say, because this is kind of weird condition. So let's just say if the info log has a length greater than 0, then we print it out. I think that's better. That's a nicer condition. Okay, so this name, this error buffer. How about that? Okay, we get an error. Ooh, is it in there? Okay, good. I always get worried that it's going to be in the running of the example, not in the compiling of it. Okay, it looks like we have an infinite recursion problem because the node type is not what we expect. We have type none. Okay, interesting. So we're type checking a primary of none, type checking an assignment. The left-hand side is a none node. So we have an assignment. Left-hand side is none. Does it have any children? No. So the left-hand side has been set to some crap. Okay. So that would have been during parsing that happened. And this is where we set the left-hand side. Wait a minute. We should be saying primary okay, declaration okay. We don't just assume that it passed. So we find which one passed the most tokens, but it still might have failed. So we need to do that. That might be why. Okay, yeah. So it actually wanted to fail. So now if we go to 35 here, invalid token expected, opening curly bracket, found plus equals. Well, here's plus equals. That's weird. There's something gone wrong with my assignment parsing, because this invalid token, this is parsing business. So I found a plus equals. I wanted an opening curly bracket. Damn, there's a lot of invalid tokens. Well, invalid token type starting with expected type. This is it. This is the error. I kind of want to see if I can find out. So I'm parsing a scope. Yeah, the trouble is that these parsing errors could happen in a valid place. Yeah, because we're doing all these attempts. Yeah, that does make it hard to figure out where the actual problem is, because we're going to get, this is going to trigger a lot of times when it doesn't actually matter. So I think it's like parsing an assignment. Parsing the left-hand side of an assignment, I guess. So I need to find one where they're both false. Here we go. They're both false. And the declaration stream is saying it expected a colon but found an opening bracket. And this one is saying assignment statement assignment. This one is saying only right and primary can contain a call. So this is still not what we were looking for. We should be inside of a for loop. Yeah, it's really hard to find, to pinpoint. Because there's so much of this try parse business. And I'm not sure what the best way to find the real. Yeah, this is going to just keep going, I feel like. So this should be parsing a statement, right? It's a for loop and it should be parsing the last part. Opening curly bracket found plus equals. That's so weird. It's kind of like it thinks this is as much as I can do, and then after that I need to find this. For some reason it's not going past there. But that should be valid. So yeah, that's string parsing. Okay, so let's go to our parse for, and this is the post statement. So this is parsing the post statement. Go here and I guess we can look at the pre-statement. Here we go. So this is the right loop, right? Yeah, this is the right loop. So let's step in. Try to parse the scope, try to parse an assignment. The assignment should be okay, but it's not. Okay, let's try this again. We have the for, and let's just double check that we're looking at the right for. Yes, we are. So we step in, step over, and this should pass, I feel like. So let's step into it. Left-hand side. Declaration should fail. Yeah. It should probably say, I want a colon. So if I go to declaration stream error, yeah, expected colon. But then if I go parse primary, oh, type. Oh, I think I copy and pasted this from somewhere. This should be left-hand side, right? Should be a left-hand side primary. Yeah. Yeah, it should be. Oh, come on. I was sure that was it. Okay. Fine. Let's do it again. Just want to be extra sure that we're looking at the right place. We are. So let's step in, step into assignment, step into expression. Left-hand side primary is okay. So the primary stream next index is 191. Declaration stream is also 191. So it's going to go with the declaration. But why? Huh. Ah, okay. They both got the same distance. Ah, because that's just the left-hand side. And it's just one token. and they're both valid start. This is both, it's a valid first token for both declaration and primary. So I think actually what I need to do is flip these so that if they both pass the same amount, we should prefer primary. It's not a declaration. If it's a valid declaration, then it should always be longer because of the colon, which is not valid in the primary. Okay, let's try that. Okay, check OpenGL error has already been declared. I think this, so that's 151. So I think this is what I was talking about before, where I thought that for procedures it wasn't working. Not parse, I think it's like type checking assignment. No, type checking left-hand side has already been declared. If it does not equal nil, yeah, so for procedures, the identifier node will exist. So I'm going to put this back in. It's kind of like, what to say, a static procedure. No, maybe that is valid. Maybe that is valid. I mean, that's what we had before, so hopefully it works. Boomstick name has not been declared. I miss one. This name. Oh, shader name also. Address in memory. Address. Task has not been declared in threading. At line 98. Right, should be a colon. Index has not been declared at 101. So we need a colon there. There we go. Okay, that was a bit of a mission, hey? What did that take? 47 minutes. I don't think we can do these default parameters. I think it's not like a 10-minute thing to add those. But you can see in the grammar now how it would kind of work. If this cat's trying to get out, let me just let the cat out. Okay, so we have this, now that we have this LHS declaration, identifier type primary, see it's very similar to what we've got down here. So I kind of want to make these assignments, but just enforce that they have to be declaration assignments. Yeah, basically they just have to be declarations. And that way they can also have equals a default. But I think that's going to be a bit more work than 10 minutes. So let's first cut off what we've done, require colon, and let's tackle some of the smaller things that we have. We have quite a few small things. So os.exit, I feel like that's quite a simple thing. And our standard library, we can have exit. I think this is going to be like one of our first uses of unsigned. equals linux.exit like that. Just basically just I want to insulate the outside world from Linux. So actually none of these should import Linux, hopefully. Yeah, because this debug one just wants exit, so it can use os.exit. That doesn't have Linux. This does have Linux because it doesn't mmap. So we'll leave that one for now. Strings uses Linux. Okay, so maybe we don't need to remove it completely yet. And this is using futex. And syscalls. Okay, so we won't try so hard to get it from there, but definitely like in our example code. So this is like a program that the user might make. We should only refer to OS, not Linux. And it looks like we already do that actually. So if we wanted to exit from here, we would do os.exit 7, you know. And then the program would hang. Probably something to do with like multi-threading business. Maybe because Boomstick starts a thread pool. There we go, finished with Xcode 7. So anyway, that was a very tiny thing actually. os.exit. That's what I was talking about before, doing vic4 and stuff. So let's put the core count down the bottom. That's a little more advanced. But let's do these. I'd like to do those. Don't need the grammar really. So in our standard library, well, actually it's in type checking. No, program I think is where we have it at the moment. Yeah, so this is putting all our built-in types. So I want to make a vic2, 3, and 4. So vic2, how is an array type structured? This is going to test my knowledge of my own language now. So it's an array of F32, and then I think there's another child, and that child I think is the length. So I think if we say like number 2, I think that's how it would work. And then that would be 3. And vic4 would be 4. I hope this is correct. And the other one that I mentioned was, that I mentioned in here was byte is an alias of U8. Byte is an alias of U8. And I actually want to make a string as a slice of bytes. Okay. That might bite me in the ass. So let's not do that quite yet. Okay. But in threading, where we declared this and said, let's move it out of here, let's move it out of there. And wherever we have threading.vic4, let's just make it vic4. Is this I think we only include threading here because mostly we use Boomstick. I think the only reason we included it was for that big 4. Where was the other big 4? Okay. Let's try that. Okay. I guess I did the structure right because it's working. Cool, that's a bit tidier. We haven't actually used the byte yet, so let's use that. One place I was thinking of was that anywhere where we have a pointer to an I8, basically what I'm saying is, in the bang code, basically what I'm saying is I want to point it to data, just some kind of data. Oh, we have this window stuff here too. Okay. So in GLFW, we also actually have I'm just going to make it like an empty struct. I don't know if this is the best way to do it, but it's going to make these empty structs. We only ever have pointers to them. So a monitor and a window. So we want to point it to a window like that. So, yeah, I think that's a bit nicer. Oh, this share is also a window, I'm pretty sure. There we go. And also I want to make that a byte. And let's see what happens. Let's see how much breaks. Any string and byte are not compatible. That's probably type coercion. So yeah, this kind of thing, I think. See, we're trying to determine whether something is a string by saying, is it a slice of I8? Really, it should be a slice of U8. Oh, so that needs to be U8, or maybe this is the way to do it. So we're saying it's a slice of bytes, but byte is just an alias of U8. So we need to say that this is a slice of U8. Ooh. I want to find I8. So is there anywhere else like that? Here we go. U8, U8. This is the type coercion code. I recognize it. So hopefully that's everywhere. Let's see. Okay. Example 142. Because my log buffer should just be like bytes, I guess. Which also makes me think that in strings I2A, see, this should be a byte buffer and a byte buffer. Also, it's probably going to cause some issues. 102, yeah, so that needs to be a byte buffer. Strings 31, I guess that needs to be, well, I guess we could call it a byte, cast it to a byte. Does that work? Yeah. Oh, and the whole thing just worked then. Okay. So I guess we did it. We have these aliases now. Querying the core count, I think I will do some bit of research. I think it's an easy thing to do once I know. It's just a little bit of Linux research. So, well, you know, syscall research. And we're coming up on an hour, so I don't really want to spend that time right now. But we do have a bunch of easy things in here. Fix ugly imports. So import space I think the ugly imports are like blah, something like that. That's how you do, I guess, like aliases in Odin. So if I say like A to Z, I don't know if there's any left actually, because I might have fixed them all now. I think there was like, was it type checking assignment? Ah, so there is one. So why didn't it find that? And oh, because it's not, there we go. It's because it was not using regex. Okay, so this is the only one. Easy. Next. Prefix dangerous modifiers with danger. I want to think a little bit about that because I might change a couple of other things with modifiers actually. But this, I think I've realized, was a useless procedure. What it does is it goes recursively until it finds, you know, you give it a type and it goes recursively until it finds one that has a value and then returns it. But the only place it's used is here. But this is where we're checking if it's a float type. And if it's a float type, then the value will be directly on this node. There's no need to recurse. Yeah, so we can just do this. It was pointless to have it. So we can get rid of it. Oh, no, I normally like to have that file open, don't I? Okay. Okay, I feel like we can do some more of this stuff. So, procedure to measure C-string length. That's something I wanted to do for a while. I think the only time where it's actually needed is here. So this returns a C-string. Yeah, I've got to say, let's say C-string, because that's more clear. Oh no, but we can't, I don't think. I actually want to make C-string an alias of pointer to byte, but that has a few more implications. So let's leave it like that for now. But then I actually want to do error length equals strings dot get C string length. Pass that in and then put error length there. So let's implement that. I think that will not be a hard one to do. So we need to go to core strings, get C string length, which is a procedure, which, yeah, I'm going to bring in a pointer to a byte right now, but we'll resolve that a bit later, I guess. And we'll return a I64. I mean, it should be U64, but that's another topic. We'll change those. We'll change a lot of things to U64 soon. Because, yeah, my preference is to use unsigned anywhere where it makes sense, because it's a more restrictive type in my mind. By saying you're saying this is never going to be negative. With I, could be negative, could be positive. So the kind of narrower type to me is better. Anyway, so what we actually have to do is make a slice. oops, raw equals, and so I'm going to say, where did we have max? Yeah, like this. So later we'll replace it with a max value. I'm just going to put 999 for now. So there's basically I'm taking this value and I'm making a slice with it, because you can't index pointers. You have to index into a slice. And then we can say length I64 and for value slice length does not equal 0. Because if it equals 0, that's the null terminator, right? So then we go length plus equals 1. In our language, we can actually do this. I'm pretty sure. I'm pretty sure I know how to use my own language. And then we return the length. What happens there? Any errors? No. So let's give it something to try. If we go back to this main file, if we revert this to just 100 like it was before, and then here we say 666, that should be an error. Yeah, so we see these errors, which I guess are 100 characters long, but these here are nulls, because the way it's stored in memory is there's all these different errors stored together with null terminators. So if we go and get the error length, we should get just the error we want. Yeah, there we go. Shows just one error for each time. Much better. Cool, so that worked. So let's put this back. All right. That was another thing I can check off the list. In-place reversal of bytes. I have to have a bit of a think about that one. So at the moment I make like this intermediate buffer, which is kind of not great. Really, we should just put things directly into the buffer supplied. But the way that I2A works is it starts from the least significant digit and then moves up to more significant digits. So the number is actually reversed. So this minus, which we are putting in first, will go to the end. It'll go on the end, so that minus will go in the wrong place. We can check that too. So here we are. So we're filling all the buffer up, and then I feel like we can make a small start to using unsigned. I feel like we can use unsigned for that length and that index. So this is the tricky part. I wonder if this is right. So while the index is less than half the length, we assign the first, we're going to have to do a temp thing, right? So we're actually going to have some braces. So we're going to have to say temporarily put this here, and then we assign this from here, and then we put temp there. It's a bit of a swap business. So the last length minus 1 minus index, which will be, so if this is 0, then it's the last character and the first character get swapped. So that sounds right to me. It's just this condition, when do we stop? So if there's an even number, so length is say 4, then when index gets to 2, that's too far. So less than half. Yeah, that's good. So what if the length is 3? If the length is 3, then we want to swap index 0 and 1. And then we could swap 1 and 1. It would just be pointless. But if it's 3, then half of 3 is 1. So index is less than 1. So I think that checks out. It's really hard to say. I mean, these numbers look right because this is printing out from I to A. But let's do a check with a known number. So I have a feeling that will be a name. So if we just say like, if we say 1, 2, 3, we get test 1, 2, 3, okay? And if we say an even number, 1, 2, 3, 4, we get 1, 2, 3, 4. But if we put negative, I have a feeling the minus is going to go at the end. Ooh. Or we're going to get a whole mess. Negative numbers it does not seem to work with. I thought it did work with negative numbers. If value is less than 0, then we put a 0, or put a minus into the buffer. Then we negate the value. And so then we're treating it like a positive value. Right? That's what I thought. But it does not seem to work. But we're at 112 now, and I don't think that's something I've just introduced. Well, I hope it's not. What if I undo this business? Then what? I8 and U8 are not compatible. No, yeah, that it was a problem before. So I'm pretty sure that is right. Okay. All right, so we don't have this intermediary buffer anymore, which is good because that was a limit. It was like only 100. Doesn't matter what size you've got here. Could have done a dynamic size, I guess, based on length of this, but anyway, we don't need it at all. And it was really not that hard to fix. I guess I was just lazy when I first did it. Okay, so that's another win. Got that one done. Yeah, slowly cutting things down. I think this is what I would like to have a go at next. Default parameters. Still adding things. These are a couple of things that I added recently. Yeah, all right, cool. Thanks for stopping by. Have a good one. Ciao for now.